Following on from some of the early videos, we got to this stage here. We got to we were trying to integrate this, and then we got to this stage here where we realized that this was a constant, so we can take it out here. That will then give us this. So let's pick it up from here. So following on from the previous video, we got to this stage here. So now you would put the b into here. So that would give you b to the power of whatever, and then you would put a 1 into here. So that would then be 1 over 1 to the power of b to the power of p minus 1. And then remember, in the case we are looking at a case where p is greater than 1. So if you look at this, p take away 1, so p will always be above 0. So even if you have 1 over 1 to the power of 0.00037, this thing here will be 1. Even if, suppose p is something else, suppose p will when you get p take away 1, let's say you've got 1 to the power of 2.3725, say, this whole thing here will still be 1. So when you put 1 into here, this whole thing here will be 1. When you put b into here, then it will give you, then this whole thing here will then give you this. So now that will then take us to here. So integrating from 1 to b would give us this whole thing here. So now allow b to head towards infinity. So take the limit as b heads towards infinity. Well, this thing here is a constant, so you can take it out here. So it was here, you can take it out here. So the minute you allow b to head towards infinity, you are no longer integrating from 1 to b. You are now integrating from 1 to infinity. So from here, take the limit as b heads towards infinity. So this thing here will then become this. This whole thing here will then become this. Now you've got to decide what happens to this block here. As b heads towards infinity, what happens to this? Let's say. So remember, p is fixed. Let's say p is this. P is greater than 1. So if p is greater than 1, then this thing here could generate this. Hang on. Let's say p take away 1. Let's remember, because here p is greater than 1. This thing here could be a very, very small number. It could be a very, very small number. Let's say this. So what happens as b gets larger and larger? What happens as b gets larger and larger? What happens as b gets larger and larger when this is really, really small? But don't forget, this here is fixed, because the minute you select p right from the start, then p stays fixed all the way through. So this thing here could be a really small number. So you are now trying to investigate what happens to this thing as b heads towards infinity. But this thing here could be really small. This thing here could be 0.0000037, say. And then what happens as b heads towards infinity? What happens? Well, before you can investigate this whole thing here, let's try and investigate this bit here. So let's just look at 1 over b to the power, let's say to the power of a half, because a half is near enough. A half is near enough this. Later on we can look at a tenth, and then later on we can look at 100th, and then later on we can look at 1000th, and so on. We can make it smaller and smaller. So we are trying to investigate what happens to this thing here when this is really small and this gets bigger and bigger. So if you look at this, this thing here is square root of x, square root of b. So you can see that this thing is going to grow. So when you have 1 divided by something that keeps on growing, then the whole thing here will head towards 0. So now let's look at a case where if you have something like this, hang on. Earlier we had to the power half. So now let's look at to the power 3. Remember, we are trying to investigate what happens when this thing here is really, really small, and then you take the limit as b gets really, really big. So now earlier we looked at a half. Now let's look at an even smaller number. Let's look at 1 over b to the power of a third. So what happens when we take the limit as b heads towards infinity? Well, let's just look at this bit. Well, square root of x looks like that. It keeps on growing a third will also keep on growing. So you know that this thing here is going to keep on growing and growing and growing. Therefore, the whole lot will head towards zero. Now let's look at something smaller than a third. Let's look at a quarter. So you've got 1 over b to the power of a quarter. Well, to the power of a quarter, we just keep on climbing. Let's look at a fifth. Well, a fifth just keeps on climbing, but it is climbing. So as b heads towards infinity, this thing here is just going to get bigger and bigger and bigger. So therefore, the whole thing will just get smaller and smaller. So looking at this, as b heads towards infinity, this is going to head towards zero. This is going to head towards zero. And so this whole block here, hang on. So this whole block here, this is going to head towards zero. So this whole block here will be -1. This whole block here, as b heads towards infinity, this whole block here will be -1. So -1 times this, then that will become this, that will then become this, and then you've got positive p, and then you've got -1, -1. The whole point here is that as b heads towards infinity, this is going to head towards zero. If you probably have to think about it. Okay, so now we've established that this thing here, when you integrate it from 1 to infinity, it comes to a finite number. Remember, p is fixed. P is fixed. The minute you set the problem, p stays fixed. So for example, this thing here, you set p to be 2, then p will remain 2 all the way through. So p is fixed. So when you integrate this, it comes to a finite number. So now going back to the theorem where it says that that if this thing here diverged, then this will also diverge. This thing here converged, and this thing here will converge. Well, now we've just established that this thing here is going to converge in the case of p being greater than 1. So we know that this thing is going to converge. So therefore this thing must also converge. So that proved it. Yeah. Okay.